In this video I'm going to solve the puzzle Giant Shoulder 2, which is shown here, and it contains three equilateral triangles, a blue, a green and a red one, and there's also this containing triangle, it's also colored red, and the question is what's the proportion blue to red? And I'm going to take the approach of Nathalie Guo, and there are several approaches, but this one I particularly like. So let's make again visible the several vertices, and what you can see is that, well, this of course is an angle of 60 degrees, and here we have an angle of 120 degrees. So that means that the quadrilateral FCDE is cyclic. So I can easily show that there's a circle which goes exactly through the 4 points. And this is very handy because if I draw this segment, then from the Thales theorem, this angle is equal to that angle, which is again 60. So we have here an angle of 60, and also this angle is equal to this angle, which is also 60. So this line bisects the angle of 120 degrees, and that means that these sides are actually, and also this one for that matter, that will come in handy later, they are parallel. You can easily see that from the angles they make with the horizontal. Now, the next thing to do is to use Ptolemy's theorem in this cyclic quadrilateral. Let's put some numbers in. So if I say, for convenience sake, that the blue one has side length 1, and that the green one has side length well, x, let's say x, and x is variable, it can vary, and you can see that like this, you can vary x, proportion stays the same as it should, and that makes that this CD is 1 minus x. And we have another x over here. And well, let's name this one y. Then you can use Ptolemy's theorem, which states that the product of this side times this side plus this side times this side is equal to the product of the diagonals. And because these three sides are equal, say length z, you can easily see that the z cancels out, and what comes out of Ptolemy's theorem is that y equals 1 minus x plus x is 1. So basically this side of this diagonal is this plus that, and that exactly is 1. So surprisingly, this length is exactly equal to this length. So we can say we can replace this by 1. Well, now, because these lines are parallel, we can calculate the areas. Let's say for the blue area, it is, if you take this as base, it is the height, which is the distance between these lines, the perpendicular distance. Let's draw it. So this distance, this perpendicular distance, is, let's call h. So the blue area is half times 1 times h. So that's h over 2. Let's put it over here. So we have for the blue equals h over 2. If we call this h. The red, you can see, you can divide red in the rectangle DFC and in DEF. So it's the sum of those. But if you do that and you add them up, you see if you take, they have the common base 1 and they have one height, small height here and another small height here, but adding them up it adds exactly again to h. So if you add up those triangles you will get that red also equals h over 2. And that means that red is equal to blue, so their area proportion is 1. And as you can see, if you slide it over here, well, here is of course it's obvious, and over here it's also obvious it's 1. But surprisingly, the whole range, the area, the red area equals the blue. And that's the answer to this puzzle.